Well, welcome to session 6. It seems like it's been a lot longer than 6 sessions, but this week we're going to talk about PC board design with KiCad. And what we're going to do is we're going to go through our, what do I want to call it? From last week we went over the RF stuff. And so this week what we're going to do is we're going to actually build out a PC board design. Let me find the document. Based off of the GQRP club data sheet. So let me get this up nice and big. And then, well, we'll just go into our presentation. So our goals is I'm going to start out and give you an overview of KiCad. We're going to use KiCad to lay out a simple RF low-pass filter schematic. And then we're going to use KiCad to lay out that schematic into an RF filter board PCB. And we're going to do this with the surface mount devices in mind. So we'll actually be, so it'll be a little bit simpler compared to doing it with through-hole devices, but everything we're going to walk through will work the same. And then if we finish that by, get that all done before the end of the session, we're going to submit, we're going to generate the Gerber files and the drill files, and we're going to submit it to a PCB factory and send them off to get made. Let me switch over here to the desktop. So we went over this QRP club data sheet last week, and this is pretty much a generic schematic for a low-pass filter that basically is designed to give maximum suppression and attenuation for second harmonics and beyond. This was created by W3NQN. I don't remember his name, but what we're going to do is we're going to design this based on in the schematic, and then we're going to make it so that we can basically do any band we want: 160, 80, 40, 30, 20, 17, 15, 12, or 10. So where some of our C1 and C7 capacitors and our C3 and C5 capacitors are set, and our C4 capacitor, instead of doing one, we'll actually put 2 capacitors in parallel. That way, instead of having to try to find a capacitor, you can't really find a 1,659 picofarad capacitor. Oh, let me let Arnav in. So what we're going to do is we're going to use standard values like a 1450 picofarad and a 220 picofarad capacitor, or a 1500 or an 150 picofarad capacitor. So what we'll do is everywhere where we have capacitors here, we'll actually put 2 down, so that we can actually put both in place. And then what we'll do is we'll be winding the toroids ourselves to create our inductors. So we'll probably they actually suggest either use T37 2s or 6s. They've got the same footprint because they're both T37. So what we'll do is we'll use like a T37 toroid as the basis for our footprints when we design the circuit board. So after that whole hour of going through all the math and all the different calculations, if all you need is a low-pass filter, which is what we need for what we're going to be doing as far as like beacon transmitters and that, then we can use this data sheet and pull our values directly from there. There's no math involved. these are all proven. They've worked quite well. And if you wanted a cheat sheet for low pass or for see, May, June, that's what I want. For bandpass filters, then okay, so Ed Weatherhold is the guy who actually wrote all these articles. He's got and I put both of these up in groups.io, but he's got another design here where it builds out and they base everything off of standard values. So so you don't really have to go out and try to find to do all the math. This is a good reference. Again, also the ARRL handbook is a good reference. But for tonight, we're gonna basically concentrate on designing or creating the schematic design around this low pass board, and then do the design the circuit board. So let me go over here to KiCad, and we'll start with KiCad. Now, when you bring KiCad up initially, it's just going to be blank. So what we're going to need to do is we're going to need to create a new project. And so I'm going to go down here to my source code directory, and I have a KiCad, and I'm going to create a do it under presentation schematics. We'll do a new folder, session 6, and we'll call this session 6 schematics. I'll just call it session 6 project. And when we do that, it starts out and it gives us a PC board, a blank PC board, and a blank schematic. So the first thing we're going to do is we're going to actually work on the schematic, and then we'll assign footprints to the components, and then we'll go over and we'll work on the PC board and add the stuff to the PC board, and then generate our files. So we'll double click on the schematic, and it's pretty blank page. There's not really much here. You can go in here and you can set up your title and everything. You can go edit, and let's see, where is it? Oh, where is it? Trying to find it here now. Here we go. So the title, we'll call this low pass RF filter W3NQN. And then if we want to, we can add in comments. We'll export that out, and we'll make this revision 1.0 and click OK. So the next thing we're going to need to do is start adding stuff onto the schematic. So if we go back and we look at our schematic here, we're going to need a connector to connect to the source, a connector to go to the load. We're going to need capacitors and inductors. So what we're looking at here is we need to add, let's see, 2, 4, 6, 8, 10 capacitors and 3 inductors and 2 connectors. So we'll start with that, and we'll add those to the to here. So the way we actually add stuff to it is we go over here. You'll see this little symbol here. It says add a symbol. And what it'll do is it'll load up the symbol libraries, and it's going to give you a pop-up here once it's done digesting them all. So the first thing we'll start off with is the connectors. So you can go in here and just type connector. And what we'll do is I'm going to look for a generic connector that is a 4-pin socket, because I want a little bit of stability with that. And then, as you see, it doesn't have a default footprint. Now you don't have to set the footprint now, but it's actually a good thing to always set your footprint if you know what you're doing. And so what I'm going to look for here is what we normally use is a 2.5 millimeter pin header. So I'm going to look for a connector that is a 1 by 2 by 4 by 2.5, and basically a pin header. So, and we want a vertical one. So I'll click there, and that sets up the footprint for it. So I'll just put one here. And now what I want to do is I need a second one, so I'm going to do Control D while that's still highlighted. And that's going to give me a second one. Oh, it didn't do it. Okay, Control Z. I'll do Control D now. There we go. And I'll put another one over here on this end.
Hey, Jim, could you show again how you got to the footprint? I didn't see that part of it.
Okay. When we click on Add, and you select an item, down here in this box here, or say no default footprint, let me find something that actually, let me go back here to what we were using. You can get a drop down.
It didn't show it first. It's showing now.
Okay. And what we're looking at is a pin header. So at 2.5 millimeters and vertical. Now the other thing we can do, I'm going to zoom in here a little bit. As you can see, so we have what looks like the pins. Let me cancel that for a second. And let me get up here and get to my, so it looks like the pins here, and then we've got the little round connectors. So those are the actual connectors that we're gonna actually attach wires to. So what I'm going to do with this connector here is I'm going to actually rotate it. And you can do that by using the stuff up here, the two icons. You can rotate counterclockwise or clockwise, or you can just press the R key. So I'm going to press the R key twice. And that way my connectors, my wire connectors, are going to be facing each other. So as I go out one and in the other, then I've got a connection. So now let me zoom back out here. And the next thing we're going to want is going to be our capacitor. So let's go ahead and add a capacitor. Okay. We want an unpolarized, small cap. Or we can just use the C here, which works as well. And then what we're going to look for is we're going to use 0603, or no, 01206, excuse me. And I'm going to set the pads for hand solder, so the pads will be a little bit bigger. So this is a capacitor SMD C1206. And the pad is 1.33 millimeters by 1.8, but it's big enough that we can do a hand solder. And see if I can get it up here closer so you can see it. So we're going to go ahead and we're going to place that. And then what I'm going to do is I'm going to go back over here to this guy, and I'm going to basically duplicate this 10 times. And I need to do 2 up here at the top in the middle. And when I place this one, I'm going to go ahead and rotate it. Probably be help if I zoom in a little bit more. And I'm pressing Control D in order to duplicate that. And then, like I said, when it's highlighted, I'm pressing R to rotate it. So now we've got our capacitors out here. We've got our connectors. What I'm going to do is I'm going to move this connector up, because what we're going to do is we're going to use pin 3 for our source, and pins 1, 2, and 4 are going to be used as a ground. And the only reason I'm using a 4-pin socket is I want some stability on that board, because you're going to be pushing it in and out of either a connector or the breadboard. So it's probably better to have a little bit of stability with it. So in order to move it, I can either right click and select move, or I can press the M key. So I'm just going to go ahead and select move, and I'm going to try to get 3 to line up with the top of my capacitors. And then let's jump back over here to the other side. And I'm going to move this one. In this case, it's going to be pin 2 that I'm going to align. And there's no rhyme or reason why I'm doing that. I just figured I want to use one of the 2 middle pins for my signal. Now, and the rest we'll use for a ground. Now the next thing we're going to do is we're going to add in inductors. I'm going to look for toroid. Let's see if we got it. Nope. Let's do inductor. So we've got an L, or we can use a coupled. We're just going to use an L. And then let's see if we can find a toroid. Come on. I know they had them in here. And I'm looking at the wrong stuff here. These are all through hole. Now let's see. Let me go down here a little bit more. Here, let's use a ferrite instead, because we're going to use a ferrite core, and then that way I should be able to find a ferrite inductor here. Come on. I don't see it.
You're in the SMD library.
Oh, am I? Let's see here. Nope. What we got here? Nope. One of these guys. It's just Inductor with ferrite core, but I don't see. Well, we'll just leave it without a footprint for now. We'll just go ahead and put these in place. I'm going to go ahead and rotate this, and then we're going to put it, the first one goes between the first group of capacitors and the second. I'm going to zoom up a little bit more. Then we're going to duplicate that, put another one here.
So, Jim, are C1 and C2 intentionally lower than the rest of them?
It probably is, because those were the first two I placed on here.
Right. I mean, I'm just curious if it was.
They were not
if I missed
intentionally
something.
placed there. No, they were not
Okay.
intentionally placed there. What I need to do is I need to move them up with everything else.
Then you probably need to move your pins over if you want 3 to be.
Yeah, I will.
At the top.
It's a good catch. When you're doing stuff zoomed out, you can't really see how close you are or how far away you are. So let's move this one.
Yeah, I always put everything on the board first and then use the alignment tools to line stuff up like you want it.
Yeah. All right, let's duplicate this one, and we'll put it right here. And then I'm going to zoom out a little bit, and I'm going to grab these two here. I'm going to move those just to make it a little bit closer here. Okay, so now we've got our schematic. We got most of all our components. Now, what we want to do is we want to add a ground, and we also want to add a source, right? So let's go ahead and see, G and D, choose ground. We could use a reference ground. They have several different ones. They have like an earth ground, clean, protective. I'm just going to go ahead and use just a regular ground. I'm going to put one here, and I'm going to put it over a little bit, because what I'm going to do is I'm going to run down here, and then we're going to run across to the other one, and then we're just going to leave 3 alone. Now, if we wanted to, we could put a ground on the other end, but we only need 1 ground. So we've got everything we need. So let's start hooking up some pins. So we're going to start here on this side. And if we go over here, underneath your power symbol, you have your wire. We're going to go ahead and grab a wire. And we're going to take 4, and we're going to click on this circle here. And I'm going to bring it over and come down, click there. I'm going to do the same thing with number 2. Bring it down, connect. And the same thing with number 1, and connect it. And then I'm going to take pin 3, and I'm going to go to our capacitor 1, and then we'll start here and go there. And then we'll hook up our capacitors to our ground. And what I'm doing is I'm just trying to replicate this here. So ours will look a little bit different because we're putting in parallel capacitors so that we can actually use standard values, but it'll work the same. What happens if you don't have a connection across that? Does that hurt your connection at all? Or your circuit? It shouldn't, right? It's just a path that is not taken. So we'll connect to L1, and then connect L1 to C3. We'll go over here, and we'll connect C3 to C4. And then we'll connect C4 to L2. Move it over a little bit more. And L2 to C5. And we'll connect C4 to C5. C5.
It doesn't matter sequentially how you connect that up, other than your lines are connected up correctly, right?
That is correct. It does not matter whether you go left or right. You do your capacitors first, then do your inductors. It doesn't matter at all.
Okay, thank you.
All we're doing is we're trying to tell the program, these are my components, and this is how they should be laid out. And so this guy is going to go over here to 2 on this side. Nope. No. Let me do that one over again. Grab that, come back this way. There we go. Now, let's go ahead and grab this guy. We'll go down. We'll connect into the ground line. Oh, he's not supposed to grab that one. That's not good.
You have to come out a little bit from the pins. It automatically connects to them.
Let's see. I just want to remove that junction.
You have to come out a little bit from the pins. It automatically connects to them when you drag across the ends.
Okay. Then let's do this then. Let's we'll just, well, here, take that. Now I'll take this one and we'll delete it and we'll re-add it so it looks nice.
Click and drag to select and then delete.
There we go. All right. Now we got one more connection to make. And that'd be these two guys here. So let's go ahead and let's connect 9 to 10. And then connect 10 down here. Yep. Funny how one is wide enough, the other one is not. Okay, so now we've got our connections made. We're at the point now where we can do a design rules check. And the reason we do design rules is each one of the PC board manufacturers have rules that, like, you've got to have this done or that done. So let's go ahead and let's see. Where's my check here? Right here, electrical rules check. We'll go ahead and run the errors check. And we're going to ignore simulation models because we're not using it. So it looks like everything's okay. Because we don't need to have our power pin driven because we're not doing simulator, so we're all right there. So we can just take and exclude all these. Let's see. Exclude this one. Exclude this one. If you were wanting to run the SPICE models and simulations, then you'd want to add those. Okay, so now we're done with our schematic. we're ready to move over to our PC board. So now we can either click here, open the PC board in the editor, or we can go back to KiCad. I'm just going to go ahead and click here. Well, he's going to load up the PC board. And so now where's our components at? Zip out, it's not there. So let's go look and see what we've done here. I want to make sure I got everything. That's everything. Our schematics. Now we'll close this down and then we'll go back over and we'll open it from KiCad here, and let's bring it up. No. Wherever. Where's our stuff here? It should have actually brought everything over automatically. Okay. I do not see anything.
Did you have to highlight it on the other on the schematic diagram for it to bring it over? Any
No,
chance?
it should have actually brought it over. I want to add that. Here we go. Update PCB from the schematic. Okay. We've got some errors. I got to do L1, L2, and L3. So, but let's go ahead and let's update it. And then close. And then place it here for right now. So let's go back over to our schematic then. And let's go set our footprints for let's see. Symbol. Let's see here. Oh, that's not what I'm looking for. Properties. Let's see. Footprint, that's what we need. Let's go back over here to the library. And let's see if we can find our toroid. Nope, that didn't pick what I wanted. So let's look for inductor through hole. Now let's see if we can find it. Pull this over a little bit more so we can see what we're looking at here. See, like we could go with something like this, which is a vertical, or we can do a horizontal. I don't think we need 25 millimeters though. We could probably get away with a smaller one. So let's try. That will probably work. That says axial. Because what we're going to do is we're going to wire those, right? And then we're going to need 2 holes to run the 2 things in. So we'll use this one. So that's a 20 millimeter. That might be still, that ought to be more than big enough, but we can go smaller. Because that's almost an inch. I don't think we need an inch. Let's do 15. That's about a half an inch. Okay. So let me make sure I copy that. So I can use that for the other one. There we go. He doesn't like all that. There we go. Save this for me for the next time. Okay, now let's go do our third one. All right, so now we've got all those, so let's save that. And then let's go back over to our PC board and update the PC board. Okay. So we'll bring these over here for now. Now this is going to be the fun game, because now what we get to do is we're going to pick. Nope, I don't want a footprint. What I want to do is I want to select it. We're going to start arranging these. So let me grab J1, cancel, and we're going to move it. So we use the same commands. You highlight something and then you click M to move it. And so we're going to just put it right here. And then we're going to take C1. Okay, thank you very much. And we're going to move that. I'm going to put it over here. And then I'm going to rotate it where my ground is matched up, and then I'll move it. Now we'll do C2. We'll move it. And then we'll rotate it. And then we'll just continue doing that. So we'll move this one over here. We'll rotate it. And then C4, move it. Rotate him. And we'll move him over a little bit more. Well, that'll be fine. Let's zoom this out a little bit and bring it over here. Man. Okay, now let's okay, I'll move C10 and C11 up here, because we're going to need it up here. him. Rotate him. Move him over here. Rotate him. Rotate him again. And get our last one. Okay, and then move L3. So already I'm not liking the footprint of these inductors, so I think we're going to change them here in a minute. So see if we can change the footprint. We'll just go. We'll go back to the go back over the PC board, but let's save this for now because those are way too big, and we're not using anything that big. So let's go look, see if we can find a smaller one. This is only 3 by 10 mils. We'll use that one instead. Well, we could use even a smaller one like that. Maybe that'll work better. And all I'm trying to do is get a desired size. I'm not using anything. It's just that I know that we're talking 0.37 inches for the size of the inductors. So we don't really need anything really big, right? So I'm trying to find something that kind of fits that size. Same way with like the pin connectors. I know that my pins are spaced 2.5 millimeters apart. So I know I needed some type of pin header that is spaced 2.54 millimeters apart. So now let's go back over here and place, oh no, tools, update PCB from schematic. Yeah, those look better. Now let's move this. Move him down here. Move. Him. And grab this guy. Move him. And when you know it that I'm not going to get a nice straight, these won't line up. Well, so we can move these. I'm going to go ahead. I'm going to move this up a little bit farther because our board's going to be centered like this. Because we're going to actually We're done here. Now, one of the things that I need to do, so right now what we've got is a board. We've got it's basically laid out, right? What we can do is we can try to shove things together, make it tighter, make it smaller. But we also need to go in and add layers. But I think if I go right now, let me save this. Let's see, where's my 3D viewer? Tools. I don't see it here. Nope. We'll go. Let's just go ahead and we'll place our copper. So we did all this on the top layer, and I should have probably talked about the appearance over here. So we're doing a two-sided board. So we have a or what they call a front copper and a back copper. And everything we've done here, we've done on the copper. That means on the top. Now, one of the things is that for our pins, do we want our pins solder points to be on the top, or what we would consider the front copper, or the bottom? And in this case, we want them on the front, so we would leave them there. If we were doing a connector, where like a socket where you'd stick it in, you'd want to put those on the bottom copper. But in this case, we want them to be on the front, so we'll leave those where they're at. So I think what we can do is we can go ahead and we can start routing tracks. So I'm going to start out here with our signal line, and I'm just going to go ahead and run tracks now. That looks like crap. Try it again. And what I'm trying to do is I'm starting my click on the center here, and then I'm dragging it down to where the center of my pad. Now let's go ahead and let's okay, and let's get in here. I'm gonna stop that for a second here. Oh, that'll work. That's pin 2. Okay, so now let's take this guy, run to here, this guy, run to here. Now, what I'm going to do is I'm going to connect these other two grounds. And it won't really matter much because we're going to actually put in a ground plane with this after I get done. It's ugly. Let's go that way. Okay, so now we've got everything connected. Get in to stay in the screen here. So let's do a design rule check and let's see what we got here now. We don't have any edges found on the cut layer, so it's telling us we need to actually come up with an outline for it. So we will do that next. So we go over here and we select the edge cuts. I'm going to come out a little bit and I'm going to grab a rectangle. And we're just going to draw a rectangle. Oh. There we go. We'll go down just one more. Now let's see how it likes that now. Do our design rule check. Did I not put an edge cut?
You cut your left trace when you did the board there.
Did I? Okay, hold on. You're talking about this one here, right?
You cut both the left and right side ground trace when you put your board too close to the. You put your board edge on top of the trace, so it just cuts it.
All right. Let me make sure if I don't have that same issue over here. Ugly looking board.
It gonna print that connector 01 times 04 pin on the board?
Yeah, we're gonna change that. Oh no, it won't. It actually won't.
Just the
So here, let me turn off.
just the stuff that's in yellow.
Let me. Yeah. Well, so. So this is the front Silkscreen.
You have to choose your Silkscreen for stuff you want to print.
Yeah. So right now, let me turn off the. That's the mask. That's the background mask. User contents. No. Trying to figure out which one that is. It must be yeah, fab. So fab is what that is. And that would be the values that you would send across, right? We won't send that to the fabricator, but we will send the front and the back mask.
Mm-hmm.
So this is what it'll look like. So that'll be our Silkscreen layer right there.
And what's the arrow there by L2?
That's telling me that there's an error with the design.
Oh, okay.
He's saying that I have a malform edge. So let's.
So you probably just need to take the top edge up higher. Is that it?
I don't think so. I'm gonna. I'm gonna put back on everything else. So let me put the background and the paste, the adhesive, and the background. So I think right now what I need to do is I need to come in here and let's re-add our. Okay, so that should take care of that one. I don't think I cut anything else off. Nope. And
J1.
J1.
Oh yeah, I see it now. Yeah.
Ground 4, yeah.
So this guy needs to go from here there. Okay. Now, see if there's anything else. No. Okay. The other thing I need to do though is this guy actually needs to be. I need it to be parallel with that one, right? So let's see if I can align those tops. So place. Let's see. I don't think they have an alignment. It's not like doing a graphics, right? But this one looks to be much lower than that one, right?
Yeah, it is.
So let's move it. Now I'm just using my arrow keys to move it, but that looks better.
That's it.
I would tighten up C7 and C8 and bring everything left.
Okay.
Bring C7 left underneath the pin for L3,
Yeah.
where it's just vertical. Kind of like L1 is. L1, C2, and C3. That's a good look.
Yeah. Now I'll bring C8 in again.
Well, C8's a good position, and then
Okay.
bring J2 in and reconnect L3, C7.
Okay. J2 in. Or you mean JC? Oh, J2 in. Ah. Yeah. Hold on. We're going to have to basically reconnect
It's
everything.
OCD engineer, you know, you got.
Oh, no, that's fine. That's just like these here. I was looking at these, and I'd like to move those over a little bit, but they don't really match up.
Yeah, short traces are good traces.
Yeah.
And the traces don't auto move with you either, do they?
No,
Apparently
they don't.
not.
Well, what do you want? What do you expect for free?
A rubber biscuit.
But I am going to like align these underneath each one of these. I'll go back and we'll.
I didn't know the traces wouldn't move. I've used KiCad a lot, but never for a PC board. So I just used circuit diagrams.
You're trying to get them to align. You want to bring your L3 in as well, Jim.
Yeah, I will. Well, the other thing is, like Roger was saying, is small traces are better traces, especially with RF, right?
Mm-hmm.
Okay, so we can bring C1 in.
Well, there are some instances where you want to separate things, so you don't have coupling between like inductors. If you had multiple bands or something like that, then you would want to separate the inductors, you know, with some kind of spacing or some kind of vertical fence to keep one section from coupling over to the other section. But for a filter like this, you know, the proximity is not going to kill you, you know.
Yeah. Well, and this, yeah, not this guy. Okay, so now I need to bring J1 in.
I'm disappointed that it didn't tie the traces together.
Yeah, I don't know if that's my inexperience or whether that's or if it's something else. But we'll fix it here in a minute.
This is better than using Gerber to build boards.
Okay, so now let's go ahead and go back and let's rewire this guy back up from here to here to here.
That looks pretty good.
Roger, I figured you were going to give me pointers.
I'm pretty good with KiCad because I use it all the time for schematics, but I've never done a PC board with KiCad.
So ground
Okay.
between C5 and C6.
Ah, well, Yeah, you're right.
Yeah,
Thank
then
you.
you
C5
got
and C6. There you
then
go.
your C3 and C3 and C4 look like they've got interest.
It's got a
oh,
turn in it.
yeah,
So the question is,
let's just do this.
It's there. It's just not elegant.
Yeah, well, here, what I'm going to do is I'm going to delete this.
And you see one, you got a little tab sticking out there. I would see
Yeah.
three rather.
that's just that whole bar. Yeah.
Yeah, now let's just reload. Man.
Looks pretty good.
Okay, now what we need to do is we need to fill. So let's take in. Let's go back over
Well,
here and.
Can you make your cut edge smaller now on
Oh
the right?
man, you know I did all that stuff on the wrong layer. Let me do something here real quick. I think I may have. Nope. Okay, it stayed all. It put all the wiring on the right layer. What were you saying, Greg?
Can you make the cut edge smaller on the right and the left now?
Oh, I'm going to.
Okay.
I'm gonna cancel. I'm gonna move this up just a little bit, and then I'm gonna bring all these in.
Oh, now it's looking pretty.
Okay. Now,
Is your grid 1 inch spacing?
I'd have to go. My grid is 2.54 mils.
I was going to say, I doubt those pads are an inch wide.
No, they're
No, I'm saying your design board grid are the big dots 1 inch?
No, they're 0.1 inch. Oh, the big dots, they probably are 1 inch. But my grid is set at 2.54 mils or 0.1 inches. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So
that's an inch.
Yeah. So we're just about an inch by 2 inches, right?
Looks like it.
Yeah.
A little over an inch, 1.1 or 2.
Now there should be a way that I can actually set. Okay, so that's on the edge cuts. Let's go back on the front copper. And I'm going to add a filled zone. So first of all, I think I'm going to click here. And I got to get in here. I'm probably going to have to make this about a 0.05 so that I get a little bit finer. Maybe ground. What I'm doing now is I'm going to draw a square around everything, and we're going to create what's called a ground plane.
Ground plane, yeah.
So everything in here is going to be a ground plane, and so that when it actually defines it and does the printout, all the grounds are going to be connected together. So that's why I wasn't too worried about these pins here and how they looked, because they're all going to end up being brought into that. Okay, so that's good there.
Are you doing a solid or a gridded ground plane?
It should be a solid. Let's double click on it. So let's see. We're going to call this ground. Shape is locked. Outline display is hatched. But this should be should give us 0.5 mil clearance around anything. Fill type solid fill. Yeah.
There you go. That's what I was looking for, yeah.
Yeah. I think a solid fill is better because that's going to help dissipate heat, right?
Yeah, it is.
Okay.
There are times where you want to use a hatch for weight and stuff like that, but for something little, we don't care. So solid is better for us.
Okay.
It's less copper to etch away. So.
Yep. Now let's go ahead and let's run another design rule check and see what we got. Oh my gosh, there's no errors. But see this. So this is what our board's going to look like after it's etched.
Kind of looks like a Viking craft.
It kind of does. Now
Yeah.
there should be a way that we can actually go over here, and there should be a. Let's see. what I'm looking for is there's actually a way to view this in a 3D, but I don't see it. So let me-
What are you trying to do, Jim?
Well, there's a 3D viewer, so you can actually see what your board's supposed to look like. But I don't see it on here anymore. I don't see it down here either.
What was the trick to let it know that everything on the bottom was a ground when you were building that ground plane?
So, so the trick was, let's go back over here to the schematic. Was first of all we added a ground symbol there, and then what?
Okay,
And then
so it
everything that
kinda
we
defined
attached
it.
to it,
Mhm.
that defines that that's one net, a ground net. And then
Oh,
when
okay.
we went back over here to the here and we added the filled zone. When I double click on it, you'll notice that here's the nets, and so we have no net and a ground, right? So I wanted to make sure that this was going to attach it to the ground net that was attached to that one ground. So making sure I selected that.
And that ground is a default value that's always up there. You didn't have to type that in.
I didn't have to type that in
That-
because it actually came over from the PC board because I added this signal. If you go over here, you'll see there's add power symbols. And anything that connects to this, it actually adds it to what it calls a ground net. What we could do
okay,
is
cool.
we could actually go over here and I could double click on this guy and we could actually give him a name. You can actually give your nets a name. So like I could name this signal and then we would see a signal as another net there.
Oh,
I
very
didn't do
cool.
that because I didn't want to get in too complex with you guys on what we're doing, but this is simpler than Fusion's EagleCAD, but it's still complex enough to get you lost. Okay, so now I just had that. There it is, view, 3D viewer. So if you hit Alt 3, what this will do now is this will actually build us. Yep. So this is what it thinks our board's going to look like. So I've already got a problem with this. Anybody know what the problem is? Other than the inductors?
Or
Well,
inductors.
Yeah,
Pins are on the
you're
wrong. The pins are on the wrong side, right?
Because you want to plug it into something.
I want to plug it into something, right? This is going to be just like our breakout boards. So
you can put them from the other side and solder them on this side. It doesn't matter.
yeah, but there's actually a
That's
way
true.
to actually move that to the other side. And what we do is we select this and we hit F. And then we're going to do the same thing with this one, F. Now let's save that. And then let's go back over here, View, 3D Viewer. Now I'm happy. Now, granted, these inductors look kind of weird, but we're going to actually be using toroids, but I think that spacing is going to be more than perfect for what we're going to do. Now, we could also brand this if we wanted to.
You should.
Yeah, I should. So now there is if I go click on Silkscreen, and actually I want it on the bottom Silkscreen, so let me turn that on. There's a way to include an image. And so let me go up here to Now that'll work. We can make it smaller. Okay, so now let's go back and let's, you notice it's not here anymore, right? It's on the
It's
back.
on the back.
So let's go over here and let's do Alt, or we'll just go ahead and do View, 3D Viewer. And I should have on my back Silkscreen if it did it right, but it's not there. Let's save it and try it again. I can't remember if that worked or not. But the other thing we want to do is also add the version of the board in that, right? So we know what board we're working with. You didn't like that.
Version Gem.0.
I'm not going to worry about it. But we will put some text in here as well. So let's, and what we're going to put is RF low pass filter V1.0. And we'll put that on the bottom Silkscreen. And we'll click OK. And we want to reverse the text. We're going to put it right here. Now let me save that. And then if we go back and Alt 3, bring this up. Now let's flip it. Oh wait, no. Could be. So there it is there. So we know what it is. Now I know there's a way to get that in there, and I think I have to actually place an SVG on there. So let's go back and see if I can, nope, cancel. Let me delete that. Let's see here. No, graphics, here we go. Icons. And this is going to go on the bottom Silkscreen. And say OK. And I also want to flip it. So let's it's not going to flip. Well, let's see what we get now. And there we go. Of course, it's backwards, but that's okay. We'll live with it. Should
Now
be a
you
way
can
to flip
flip it before you import it.